Okay. Good morning, students. Okay. Yesterday we have seen some standard derivatives of some functions. Okay. Now we'll see what is the exponential function. Right. Good morning, children. So, any doubts in yesterday's homework? Any doubts? Okay. Can I continue or else any doubts are there? Okay, good. Now we'll proceed. What is exponential function? We define new functions and find the, we are going to define different type of functions and then we are finding the derivatives of that function. I told you this chapter of differentiability, we are totally depending upon derivative, finding the derivative of every function. So function of the form y is equal to f of x is equal to b power x, b greater than 1 is called base exponential function. So any function of the form b power x, right, where b is greater than 1 is called the exponential function. The range of exponential function r plus, because only you get point integers, domain of exponential function is equal to any real number. This is about function. Okay. Now, what is the base is note. If the base b is equal to e, then it is called natural exponential function. As y is equal to f of x is equal to e power x. Again, if the base b is equal to 10, then it is called common exponential function, as y is equal to f of x is equal to 10 power. So you understood from the exponential function, natural exponential is one criteria and common exponential function is other criteria. Are you clear? So what is exponential function? Any function of the form f of x is equal to b power x, b greater than 1, because e and 10 are also greater than 1 only. Okay. And it is called exponential function. The domain is r plus, r, and range is r plus. And if instead of b you get e, because e lies between, what is e, you know? E is equal to 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus etc. That is 1 plus 1 plus 0.5 plus 0.16 plus etc. So 2.66. So it is irrational number. E is a non-repeating, non-arithmetic rational number. Okay, something will get. So what happens? 2.67 like that will come. Okay. So what you get, it is non-repeating, non-repeating. E is more than 1. So E lies between 2 less than, E less than 3. So E is called the exponential, natural exponential, or E is the base, right? So for the function f of x is equal to b of x, if b is nothing but equal to e, then it's called natural exponential, and b is nothing but 10, it is called the common exponential function. From these two parts, we'll get the logarithm also. This is, from this you'll get natural logarithm, you call it as log ne or ln. Okay, natural logarithm, or this is Briggs logarithm. So all the logarithm values what we see in solving the chemistry, numericals, physics numericals, that is called common logarithms. And what are the theory principles we use in derivations? Okay, in the what you can say formulae of physics or chemistry, they are called natural logarithms. So calculation is the Briggs logarithm or the base 10, and this is natural logarithm. From the exponential function, we are able to convert the logarithmic function. We will see how to do it. Okay, exponential to logarithm and logarithm to exponential. First, are you clear what is exponential function? So make a note, then we'll proceed. Please note down. Okay, noted? Yes. Next. Next. Some properties of exponential functions. Okay, we'll see here. For large negative x, the exponential value, the exponential function, value reaches to 0. So example we see here, y is equal to 2 power minus 1 lakh. Suppose you took here 10 lakhs. So 2 power greater than 1 only, 2 power minus 10 lakh means more than 1 by that you get. So what happens for 2 is equal to, sorry, I got a important matter to attend. 2 per minus 1 lakh, what happens? This value is equal to 1 by 2 power 1 lakh. It is equal to 1 by almost 10 lakhs. Means 1 crore, like that you can take, which is equal to 0.701. Okay, so for large value of x, negative value of x with the base b, exponential value becomes 0. So for x is equal to what you can say, for any x, for any point 0 comma 1 is the compulsory point on the graph. Suppose y is equal to b for x you took. Okay, are you clear? Y is equal to b for x. So what happened? Y is equal to b for x. Then if x is equal to 0, then y is equal to b for 0, which is equal to 1. So for any b, 0 comma 1, or for any gb, 0 comma is the compulsory point on the graph. Are you clear? For any b, 0 comma is the compulsory point on the graph. Okay. So now this is the property of exponential function. Are you clear? This is the property of the exponential function. Note on this part. Again, what is the other property? The value of exponential function is always increasing. Means for x is equal to 1, y is equal to, what you can say, 2 power 1. You take here, suppose x is equal to 2, y is equal to 2 square, 4, x is equal to 3, y is equal to 2 cube, that is equal to 8, etc. Okay, so what is not the point? How you will take the graph? This is 1, 2, 3, 4, 2, 3, 4, right? X is equal to 0, y 1. X is equal to 2, y 2. X is equal to 2, y 4. X is equal to 3, y 8. Like that you will get the curve. Okay, it's an increasing function or not? Okay, so always it is an increasing function. So note on this one. Yes. Okay, noted, right? Next. See, for natural exponential function, what happened? Okay, for natural exponential function, always derivative has no change because E is a constant. Since E is a constant, because d by dx of e power x is equal to e power x only. It has no change. Why? Because that we have done, right? And by first principle, last year we have learned f of x is equal to limit x tends to 0, f of x plus h we have substituted e power x standard limit you will get. So e power x, derivative of e power x, natural exponential function has no change. This is fixed. Okay? Is one more thing. One more thing is that if there is no base taken, we can assume it as base E as natural. Suppose y is equal to f of x, right? That is equal to 2 power x. Okay, then base is 2, right? So then what you can say, if you convert this into log y to the base x is equal to 2. That is logarithm function. Y is equal to 4x, then log y to the base x is equal to 2. Let's 2 cube is equal to 8. Then log 8 to the base 2 is equal to 3. Like this. Okay? Similarly, y is equal to e power x. Let's log y to the base e is equal to x. So this is exponential to logarithm. Exponential to logarithm base. Okay, are you clear? This is called exponential to logarithm. So note on this part. Okay, noted? Yes. Next. Next, logarithmic function. What is logarithmic function? If y is equal to 2 power x, then log y to the base 2 is equal to x. So this is exponential and this is logarithmic. Similarly, If y is equal to x power n, then log y to the base x is equal to n. Similarly, exponential and logarithmic. Similarly, b power x is equal to a, then log a to the base b is equal to x. You understand how to convert natural exponential to the logarithm? Okay. So every exponential function can be converted to logarithmic function. Are you clear? Okay, noted? Right. Now see here. We'll see the definition of logarithmic function. Logarithm function we define if b belongs to r plus and b greater than 1 is a positive real number and greater than 1, then we say logarithm of base of a to base b as log a to the base b is equal to x if and only if b power x is equal to a. So logarithm of a to the base b is equal to x, so b will be taken down and x will come down. So log a to the base b is equal to x. 2 cube is equal to 8, so log a to the base 2 is equal to 3. 2 power minus 4. 10 power minus 4. So 0.001. So log 0.001 to the base 10 is equal to minus 4. Are you clear? Any number power base cannot be negative, right? So logarithm of negative is undefined. Are you clear? You take negative in the power also, what happens? The value of the function expression or the exponent cannot be negative. So then logarithm of negative cannot be defined because you will never get negative for any exponent. Okay? Note down this one. Since for any exponent value is non-negative, the logarithm of negative number is not defined. So any power for any exponent, okay, right? For any negative exponent, okay, value, it has a negative, right? Is a log value is non-negative. The logarithm of any number is not defined. You take any number, minus 100 also. What happens to this value? It becomes decimal only, nearest to 0 only, but never be negative, right? Because 10 power minus infinity also equal to, almost equal to 0. So logarithm of, you will not get this value as negative. So automatically logarithm of negative cannot be coming. So logarithm is defined only for positive real numbers. Note on this part. Hence, log is defined for only R plus positive real numbers, but not negative. Are you clear? Then any number power 0 or power anything, any number power anything will be equal to 0? No. So logarithm of 0 is also not defined. Not on this part. Since any power of any number is never 0, hence log of 0 is not defined. So for any x power n is not equal to 0. Irrespective of x, whatever it may be, now positive or negative or anything, x power n cannot be equal to 0, so hence log of 0 is not defined. Are you clear? Right. Note of this part, these are the properties of logarithms. Noted? Okay. Now we'll continue. Okay. We'll see here. Therefore, logarithm is a function defined from positive real numbers, to real numbers. Okay. Because your domain will be only positive, you can't take negative value for logarithm. Okay. So what happens? It can be defined as log r plus to the base b. Okay. To the r, because r plus to r, like that you can take. Are you clear? Is equal to x implies b power x is equal to y if for all y belongs to b power y is equal to x. That implies b power x is equal to y. For all y belongs to r plus and x belongs to r. So what you can say, b power x is equal to y implies log y to the base b is equal to x. B power y is equal to x means log x to the base b is equal to y. This is way of different. Understood now? Exponential to logarithmic, it is the conversion. Okay, noted. Next. So your base b is equal to a, it is called natural logarithm, and your base b is equal to 10, it is called common logarithm. Okay, so base b is equal to e, that means if log x to the base e is equal to y, that means x is equal to e power y. Log 2 to the base 10, right, 0.414. Therefore 10 power 0.414 is equal to, so like that. This is natural logarithm, this is common logarithm, common log, this is natural log. Have you understood? This is tablet, already you know these are tables, right? This is nothing but you know it has a table. Tables means logarithmic tables you will verify log 2, log 3, right? Likewise you can take, okay? Next one. So you understood what is a natural logarithm and what is a common logarithm, exponential function, and again conversion to exponential function to logarithmic function. Now we'll study the properties of these three functions. Okay, right? The domain of properties of logarithm functions. Okay, so the domain of log function is r plus, and the range is r. That we told because so the log of 0 is undefined. So log is defined only for greater than 0. For any x greater than 0 only. That is called the logarithm is the of 0 is the undefined. Next. The log function is always increasing function. That is from left to right, the value of x increases, then the value of y will be rising high. Right? Next. But the point 10 always lies on log function graph. 10 because 0 1 lies on the exponential function, and logarithm is reverse reciprocal because domain will changes to range, range will changes to domain. So logarithm value the function is the 10 will lie. In exponential function 0 1 will be lying, and for logarithm function log 1 is equal to 0. Therefore log 1 to the base 10 is equal to 0 implies 10 power 0 is equal to 1. Therefore the point 10 lies on graph of log function. Good. Okay, noted. Next. See here. Y is equal to e power x. Y is equal to log x. Right? Y2. And y3 is equal to y is equal to x. So, if we plot the graphs of the following functions, right? Now we see here the graph. Y is equal to x will be like this. Positive 0, 1, 1, like 1, 2, 3, 4, 5. 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Minus 1, minus 2, minus 3, minus 4, minus 5. This is 5. So y is equal to x is the graph like this. Okay. Now y is equal to e power x. So y is equal to e power x. I get here. So x y x0 y1 x minus 1 e power minus 1 is 1 by 2.5 2.6. So 0.03. X1 y is equal to 2.6. E power minus 1 1 by 2.6 0. Okay. Now x0 y1, this is that only. X minus 1 y3 5.3. X minus 2 like this. So you will get the curve like this. Next, y is equal to log x I take here. X and y. X1, y0, x0 undefined. X minus 1 also x2, log 2 0.3010, log 3 0.4771 like that. So x1, y0 here, log 2 is equal to 0.3010, right? So log 3 0.474 like this will get. So what happens to this? So these two are mirror images, right? So with respect to this, what happens to this? So automatically, if you will not get like this, you have to go down. Okay. So if you get this value, not for this way, slowly, and this value will be this one. So what happens to this value? Minus value log minus 1 2.61 minus 2 what comes here? 1 log 2 will come this square. So 0.9 something 6.76. 2 is equal to 6.16 meter. So like this will be. So you will get the this value you will get, this is the error, okay, then you will get this value and this value like this. value, which is called a mirror images. The function y is equal to e power x and y is equal to log x are mirror images for y is equal to x. Okay, this image will be equal to this one, like this will get. What happens to this? So automatically you will get like this. So this value will be taken as like this. Slowly you can get here. So this is this function, this is this function. So automatically what happens? This is e power x and this is log x. These two will be the mirror images like this for y is equal to x. So then indirectly this image the reciprocal is this and this is the reciprocal is and this is the plane mirror. This is the plane mirror. You can see images are reciprocal to each other. So this is the standard function for y is equal to e power x and y is equal to log x. So exponential has their relation with respect to log and log has their relation with respect to exponential. Now are you clear? So tomorrow we will continue. Properties and all, and I will send the homework to you. Okay? Thank you.